In this unit, we're going to take a look at electrical energy, specifically how we measure electrical energy and power, and a couple of the units that go with it. Electricity is very, very common. We use it every single day, and it's how we transport most of the energy that we use from one place to another. We have big coal burning and nuclear power plants and hydro plants that produce this electricity, and then we plug into the wall to use it. So we want to be a little bit more familiar with their units and how to measure electrical energy. So the first thing we have to do is figure out the units that we use to measure electricity. Volts are a very common unit. We know household voltage is 120. Computers usually run around 5 or 12 volts. Your iPhone uses about 5 volts. So what is a volt? Well, a volt is a joule per coulomb. And that is really not all that interesting. What does that mean? Well, joule is a measure of energy and coulomb is a measure of charge. So what we think about when we think about this is we try to put it in terms of something we understand, like gravitational potential energy. So if I have a boulder on top of a cliff, it has gravitational potential energy because it can fall down. Well, charge also gets potential energy, not because gravity is going to pull on it, but because of a charge separation. So a battery has a positive side and a negative side, and so we have this positive side and a negative side, and that means all these negative charges want to get to these positive charges. And the greater the separation between them, the greater the potential energy. The more charge there is, the greater the energy. So voltage sort of refers to the potential energy of an electric charge. Now, there's also the kinetic energy part of it, and that's the rate of flow of charge. And we measure that in current, and current actually has units of amps. And 1 amp is a coulomb per second. So this coulomb isn't a measure of charge, so this is charge per second. Now, for some reason, current gets the symbol I. Volts get the symbol V, current gets the symbol I. Not sure why. And we measure current using a device called an ammeter. We measure a voltage with a measuring device called a voltmeter. So really not that shocking there. Now, if we put these two things together, we actually get power. Power is not energy. Power is the rate at which energy is used. So a high power thing draws lots of energy and uses it quickly. And it's measured in watts. 1 watt is a joule per second. So that makes sense. Joule is energy per second. So rate at which energy is used is power. And it can be calculated for electricity by multiplying voltage and current. So what I mean by that is when we take power, we can just take volts times amps and get watts. And that's really, if you think about it, that's joules per coulomb times coulombs per second. So the coulombs cancel, and this is joules per second. That gets us power. Now, power is not actually a unit of energy. It's energy per second. So if we multiply it by time, we get energy. So power times time equals energy, and that energy will be measured in joules. So let's look at how you're actually going to build a circuit to test this. You're going to use a hand generator, which you can put work into, and it has 2 leads that come off of it. So it's got a handle that you turn and a handle that you hold on to, and this whole thing is connected up to 2 electrical wires, right? And these 2 electrical wires, one side of them is going to go to a light bulb, and this is my light bulb. The other side of that, there's going to be a current sensor here, and so I'm going to just put a big block here that says A for ammeter, and that's going to get hooked up here. And so you have an ammeter built into your circuit, and you have a light bulb built into your circuit. You're going to crank this thing, light bulb's going to light up, and your ammeter will tell you how much current is flowing through there. But your voltmeter is just going to rest across the side like this, from one side of the light bulb to the other. That'll tell us how much energy is dropped from one side of the light bulb to the other. So you'll measure voltage across the light bulb and current through the ammeter, and you'll crank this handle and you can measure the power that you're producing and the light bulb's consuming, and that'll allow you to actually get energy if you time how long you crank and multiply your power times time.